Now I shall discuss some terminologies used in the thermodynamics or in the thermodynamics. The one term which is used in the thermodynamics is a spontaneous process and the non-spontaneous process. The term used. Spontaneous process is will proceed automatically. There is no need of giving any external agencies or need of any external energy. There is no need of activation energy. So, or it may require a small activation energy just to start the process. And once it starts, the rest will proceed without the need of an external energy source. The good example is the combustion, the burning of a substance to produce a heat and energy. You may have a light the substance first, but once the substance is burning, it continues. Like water flow. The water flows downhill spontaneously. We cannot reverse the direction of flow of water with some external aid. Or the diffusion of solute from a more concentrated solution to a less concentrated solution. When these are brought into a contact, proceeds spontaneously till the concentration becomes uniformly or the same till the equilibrium is attained. But this process cannot be reversed because once the concentration becomes uniform, it is not possible to make spontaneously one part of the solution more concentrated than any other part. Then even electricity flow spontaneously from a point of higher potential to a point of lower potential. The direction of flow of current can be reversed only by applying the external field in the opposite direction. That is a non-spontaneous process. And even okay, these are a few examples for a spontaneous process. And if the reaction, that process that take place with the help of an external energy, activation energy, then that process is called a non-spontaneous process. A good example is the photosynthesis, a process in which a plant used to make a glucose. A photosynthesis requires energy, and that energy is derived or taken by the sunlight to drive a chemical reaction. And this reaction takes place only at daytime, not at night. And this is a non-spontaneous process. Okay, spontaneous and non-spontaneous process. So this is a good example for spontaneous and a non-spontaneous process. When a monkey sees banana, spontaneously it try to take. So this is a spontaneous process. Okay? Then the next term is a enthalpy. Sorry, spontaneous. Enthalpy. Enthalpy usually expressed in terms of H, the heat change enthalpy. Enthalpy is a property of thermodynamic system defined as the sum of the system's internal energy and the product of its pressure and its volume. If the reaction takes place, that time usually either the heat energy is evolved or the heat energy is absorbed. So we usually consider the system and surrounding. So heat energy may be absorbed by from the surrounding to the system, or the system may give heat energy to the surrounding. Based on this, we can consider like exothermic reaction and endothermic reaction. In case of endothermic reactions, it usually absorbs heat energy from the surrounding. Whereas in the case of exothermic reaction, so system gives out heat energy to the surrounding. This enthalpy, the change in heat energy, usually expressed like it depends on internal energy of the system and the product of its pressure and volume. So it expresses H is equal to U plus PP. Or we may express like delta H is equal to delta H is equal to delta U plus P delta V, where delta H is equal to is considered as H2 minus H1, the initial and the final variation in the enthalpy. Okay, that is the a small change in enthalpy. Usually we express in terms of delta H. So usually, if heat energy is absorbed from the surrounding to the system, then enthalpy increases. If heat is given to the surrounding, then enthalpy decreases. Based on that, we will consider endothermic and exothermic reaction. If delta H is positive, then that is, if enthalpy of a reaction is a positive, then the reaction is considered as endothermic. If the reaction is endothermic, means delta H is positive. If delta H is negative, then the reaction is exothermic. That means heat is given to the surrounding. Okay, there are two exothermic and endothermic reaction. If delta H is positive, then the reaction is endothermic. If delta H is negative, then the reaction is exothermic. So we can express like this. Here a chemical system, to that if you add one reactor to one reactant, if you add another reactant, the reaction, during the reaction, the heat may be absorbed from the surrounding or it may give to the surrounding. See, if heat energy during the chemical reaction, if heat energy is given to the system, then that reaction is considered as exothermic reaction. So delta H is negative. In case of endothermic reaction, here the heat energy moving to the from the surrounding to the system. So delta H is positive. Okay. The next term here, enthalpy delta H is equal to delta U plus delta V. Then internal energy, here what we considered here is enthalpy is related to delta U or U, internal energy. Then what is internal energy? It is the sum of the kinetic energy and the potential energy in the substance. Okay, a sum of kinetic energy and the potential energy of the substance is called as a internal energy. Internal energy is defined as the energy associated with the random or a disorder motion of the molecules. There may be an order motions if the particles are bound together with a good bonds, then a highest internal energy is observed. The internal energy, also called as a thermal energy, is the energy of an object or a substance due to kinetic and potential energy. Okay, associated with the random motions, and it is energy usually expressed in terms of kilojoule or joule. And the next one is entropy. That are what we observed is a entropy. It is a measure of randomness. The entropy is the measure of randomness of energy in a system. A measurement of degree of randomness of energy in a system is called entropy, and it is expressed as S, entropy. The change in entropy is delta S, expressed as delta S, that is S2 minus S1. Okay, that is what we called it as a change in entropy. And the lower the entropy, the more order or less random is observed. That means as the randomness entropy decreases, the system is more considered as a more ordered arrangements. The order arranged system is observed. And here for the entropy of a irreversible system, we can express the change in entropy is delta S equal to Q by T, reversible reaction. The quantity, the Q by, it is usually expressed in terms of Q by the change in entropy for a finite change of state of a system at constant temperature is given by delta S is equal to Q by T, reversible. It is a state function and it is an extensive property depend upon the amount of substance involved. Here the amount of heat absorbed reversibly by the system from the surrounding at a temperature T. Q is a quantity of heat absorbed from the system to the surrounding at a temperature T. It usually measures the randomness of the system, measure the unavailable, or in other words, it measures the unavailable energy. For a spontaneous process, entropy is always positive. Say like spontaneous process may be a melting or dissolution, melting of ice. Here, ordered state to it moves to disordered state. Ice are ordered arrangements. From ordered state to when it moves to a disordered state, the randomness increases. If the water freeze and forming ice, then again here what we observe, the ordered arrangement is observed, the entropy decreases. Okay, from in all spontaneous process the entropy is positive. The next term is a free energy. It is free energy is a the energy. It is defined as the maximum amount of energy available to a system to perform useful work. Here, the sum work is nothing but the sum of total of entropy change of a system and the surrounding, which serves as a criterion for a spontaneity or feasibility of a process. Mainly, this free energy change, it tells about the feasibility of the process, or the entropy that tells about the feasibility of the process. If the total entropy change is a positive, then the process is feasible. If it is zero, the system remains in a state of equilibrium. The system remains in the state of equilibrium. If the process is feasible, then entropy should be positive. If it is zero, the system remains in the state of equilibrium. However, in order to decide about the feasibility of a process, we shall have to know the entropy change of the system as well as that of the surroundings. This is not always convenient. Entropy change in terms of other state function also be determined. Like the other state function, what we observed is a free energy change. It is defined as the maximum amount of energy available to a system to perform a useful work. So it is usually expressed based on a Gibbs-Helmholtz equation, that is delta G is equal to delta H minus T delta S. See, delta G is considered as a Gibbs free energy change, delta H is an enthalpy change, T is a temperature, and S is the energy which is lost in disordering the system. That is what we call it as an entropy change, or gives a free energy change, which is equal to total energy change for a system minus energy lost in disordering the system. If the reaction is exothermic, then delta H is negative. The entropy increases, or delta S is positive. So based on that, for a spontaneous process, delta G is negative. Delta G is negative means the reaction is spontaneous. If the reaction is a spontaneous, we observe delta G negative. Delta G, if you get a positive, means the reaction is non-spontaneous. Okay, but the reaction is spontaneous at all temperature. In most of the reaction, what we observed is a spontaneous reaction. In that, free energy change of a reaction is negative. For all spontaneous process, free energy change is negative. Now, coming to the first law of thermodynamics, is a law of, it is also called as a law of conservation of energy. The first law of thermodynamics is also called as a law of conservation of energy. State that the energy can neither be created nor be destroyed. Energy can only be transferred from or changed from one form to another. So this law, what we called it as a law of conservation of energy. Energy can neither be created nor be destroyed. Energy can only be transferred or changed from one form of energy to another form. Example, turning on a light would seems to produce energy. However, it is an electrical energy that is covered. So the first law of thermodynamics, we relate into the equation, that is delta U, that is change in internal energy equal to heat absorbed to the system minus work done by the system. The change in internal energy of the system is equal to heat added to the system minus the work done by the system. So it is in this way we can express the first law of thermodynamics. So we can observe from the picture, light energy is converted into chemical energy, or chemical energy can be converted into electrical. During this conversion, there may be a little loss of energy, but it is not possible to create or completely destroy the energy. We can convert one form of energy to another form of energy. That is first law of thermodynamics. Then coming to the second law of thermodynamics. The second law of thermodynamics says that entropy of an isolated system always increases. So the entropy of an isolated system, it's always increases. In simple way, the entropy of the universe always increases and never decreases during the course of any spontaneous reaction. If you consider any spontaneous reaction, the entropy of the system increases. It will not decrease, or it will not remains the same. It will, entropy of the system decreases. In case of non-spontaneous, we are not considered. In the second law is mainly considered the spontaneous process. The second law of thermodynamics says entropy of an isolated system always increases, or the entropy of the universe is nothing but an isolated system. It increases and never decreases during the course of any spontaneous process. Isolated systems spontaneously evolve towards thermal equilibrium. Isolated system means it always move towards the equilibrium, that is heat flow from a high temperature to the lower temperature. It is a spontaneous process, that is it reaches the equilibrium and the state of maximum entropy of the system is observed. Or even the block of ice, so it melts, so entropy increases. Okay, this law helps to predict the spontaneity and the feasibility of the process, that I already discussed during entropy of the reaction or entropy. The second law of thermodynamics tells whether the reaction is a spontaneous, or you can predict whether the reaction is spontaneous or non-spontaneous process. Okay.